Hi everyone, welcome to the part 2 of the video tutorial on Lifecycle Assessment with OpenLCA Software. I hope you had a familiarization to the OpenLCA software and how to freely download it from OpenLCA website and inserting available databases and available impact assessment methods into the software. If you still feel new to OpenLCA software, I strongly recommend you to first go through the part 1 of this video tutorial a few times. In this part 2 of the video tutorial, we are going to see how we can conduct a lifecycle assessment in OpenLCA. Okay, before we move to the OpenLCA software, I would like to talk about the standard LCA procedure for more understanding. In ISO 14042-44 framework, there are 4 phases or steps of lifecycle assessment. Let's understand how we can apply these 4 steps in lifecycle assessment through an example. So I took a typical example, that is a product lifecycle comparison for the packaging material selection. Let's say we want to find the environmental impacts of PET bottles, glass bottles, and aluminium cans. The objective of doing this lifecycle assessment is to determine the environmentally least impactful packaging option. The first step is goal and scope definition. It is clear that in this example, the goal is the evaluation of life cycle environmental impacts of the 3 packaging materials. For scope definition, we must specify the application or the audience of this life cycle assessment, that is the decision making or decision makers or policy makers on product design and development through packaging method of the product. Also, functional unit and system boundary must be clearly specified. In this case, the functional unit can be 1 unit of packaging of a beverage, because we know that these bottles or cans are used for beverage packaging. So here the product is a beverage. So this beverage could be soft drink or beer as an example. For example, we can take the same unit of beverage like packaging of 500 milliliter bottle or can. Then it is product based comparison, and the amount of PET required to package a 500 milliliter bottle is different from the amount of glass required for the same size or the same volume of the bottle. If the purpose is just comparing the packaging materials, then we have to take a unit of packaging material, that is an example would be 1 kilogram of each packaging material as the functional unit. So here the selection of functional unit is very important. So like this, accurate selection of functional unit is critical before conducting a life cycle assessment. Then the next important thing is the definition of the system boundary considered for the life cycle assessment. The location, sub-processes, and exclusion of any process or any inventory data from the consideration for life cycle must be clearly defined. After proper goal and scope definition, inventory data collection and analysis is performed as the second step. As listed here, we can draw a mass flow diagram of the product system based on the system boundary definition. Then go for data collection methods for resources, raw material use, and emission data of the system boundary processes. Some of the data sources would be lifecycle databases, commercially available and published literature like available reports, scientific papers, and research publications. Then data collection can be performed as on-site investigation, expert knowledge, or qualified guesses based on the requirement. Then we have to calculate the amounts of each mass flow using various methods like iterative procedures, design calculations, process simulations, and many more other calculation methods. This is how the collected lifecycle inventory data should be arranged or organized for further analysis. After inventory data analysis, the third step is environmental impact assessment. There we have to translate every inventory result into potential environmental impacts. The impact assessment method must be selected according to the scope definition. In this example, I selected recipe midpoint world method because there is no exact impact assessment method for the selected location. This is how the inventory data are translated into corresponding environmental impacts. The characterization factors for each inventory data and impact are different according to the selected impact assessment method. So this is why the selection of the impact assessment is also critical for accurate interpretation of the results. Interpretation of results is the last step of lifecycle assessment methodology. Here you can see the relationship between the midpoint and endpoint assessments. In this case, midpoint assessment was selected because it's enough for the comparison of three packaging materials systems. Okay, now I hope you are much more clear about the standard lifecycle procedure that we must follow. Now the thing is how to use OpenLCA software to model a life cycle for the evaluation or analysis. Let's take an example case and try to model the related life cycle in OpenLCA software. With the available time for a short video tutorial like this, I selected a case for a coal power generation plant. Here you can see the collected inventory data for the three process stages. Those are coal mining, coal transportation from the mine to the plant, then finally coal combustion and generation of electricity in the coal power plant. Here only airborne emissions were considered because the major emissions and the inventory data are related to airborne emissions in a coal power generation process. And also kindly consider that this is just an example for explanation and demonstration of OpenLCA software. So this is not a real case study, and these data are also not from a real case study. First, let's calculate the inventory data based on the functional unit, that is 1 megawatt hour of electricity generation. Here in this table, we can see the calculated inventory results. When we calculate inventory results, the system boundary can be defined by three major approaches. They are cradle to grave, cradle to gate, and cradle to cradle. Here in this example, we selected cradle to gate system boundary. The difference is that we have to expand the selection of sub-processes in the life cycle if we use cradle to grave or cradle to cradle system boundary. Okay, now in order to model this life cycle in OpenLCA software, We have to clarify the elements in OpenLCA software that represent the levels of a life cycle. These levels are flows, processes, product systems, and projects. First, what is a flow? A flow would be one inventory data relevant to a mass flow. For example, in this case, one emission flow for 1 kilogram of coal mining. We can say carbon dioxide emission per 1 kilogram of coal mining. That is one type of flow. So like this, we can define the flows in OpenLCA software that is related to our life cycle. Then what is a process? For the previous example that we discussed for explaining flows, at there the process is coal mining. The example for the flow that we took was carbon dioxide emission in coal mining. Then the process is coal mining. I hope it's clear for you. Then what is a product system? So it is a collection of several processes. In this case, we can define the processes as coal power generation. In this case, for coal power generation life cycle, we can define three processes. They are coal mining process, coal transportation process, and coal combustion process. So these three processes together we can define as the product system. So in this example, modeling up to product system is enough. If we need to compare two life cycles, then we have to define a project that can be included with many product systems. Like in the first example that we discussed to explain the LCA standard life cycle assessment methodology, there were three product systems. They were PET bottle, glass bottle, and aluminium can. So there we have to use project. We have to use project element in OpenLCA for comparing several life cycles. Further, we must learn how to import or export existing data from databases as well as life cycle impact assessment methods from previously downloaded files from OpenLCA Nexus website. I showed you how to download these databases and lifecycle impact assessment methods from OpenLCA Nexus website in our part 1 of this tutorial. Okay, we had to explain a lot rather than just showing you how to do it in OpenLCA software. Now let's practically model the example case in OpenLCA. I'm doing it in a blank new database. I showed you how to create a new database in OpenLCA. How to do it? You can right click and click a new database. So this is my previously created new database. So here you can see, as I explained previously, the 4 elements that we use to model a life cycle are available. They are flows, processes, product systems, and projects, as I explained previously. Then we have to enter some mass flows for related to our life cycle considered. But in this case, we have only airborne emissions. So if you check the new database, the elementary flows, air and resources, soil, water, they are available already. Apart from these elementary flows and other basic flows, if you have any new flow in your life cycle or the system boundary, then you can insert that new flow by right clicking on flows and click on new flow, right? But here I'm not adding any new flow.
because I can use the existing elementary flows. If I show you if I expand the elementary flows, we can see the emission to air. And normally coal mining is happening in low population density area as well as coal power generation plants. So if I check the low population density, we can see a huge number of elementary flows are available here. So what I need would be basically carbon dioxide would be the first thing. So if I check, I can see that several carbon dioxide entities for inventory data or inventory emissions are available. So like this, we can add our flows available from elementary flows here. So for this example, we don't need to create any new flows, and we can directly go to processes, and there we can enter 3 new processes. They are first one is coal mining process, the second one is coal transportation process, and the third one is coal combustion process. So how I enter a new process? So I will first show you how to enter the coal mining process here. So I will type as coal mining, and then we can select create a new flow for the process option, and then reference flow property. We can actually even though we changed, I mean we calculated the inventory data based on functional unit in our example, it's not necessarily be done required to be done here. We can go with the reference flow property as mass, because the raw data that we have is per 1 kilogram of coal mining. So we can use that basis for this process, and later on we can convert it. There is also one way. The other way is we can directly enter the data based on functional unit here. So I will directly select okay, so I will select the mass and I finish it. Then I can see that I have created the coal mining process. So here I can enter the inputs and outputs data, inventory data in this coal mining process. We can see the second tab here. Actually, the inputs in this case for coal mining process would be some energy inputs for mining operations, and for mining vehicles there can be some fuel consumption. So like that, there would be several inputs, but those inputs will be ultimately represented by the outputs. Since in this case we have defined the emission data, those emission data correspond to energy inputs for the coal mining process. Thus, we can simply show the airborne emissions as the output data, but we can show some energy elementary flow as the input in this simple example. So what I will do is, I will how can I enter some available flow? So I will go to elementary flows, and here I want to enter some resource data like energy consumption or something. So then I will go to ground, and in fact I will select coal hard unspecified, because since the energy inputs are corresponded to emission data, here we can show as the input simply as the coal rock, or the ground material that we use to mine to obtain purification processes and there can be some mechanical separation processes to obtain the bituminous coal or whatever the purified coal for the power generation process. So here I entered the and it would be in fact to obtain 1 kilogram of coal that we require for the power generation process. There might be around 1.1 of coal, because there can be some loss when it comes to the output. Then we can enter the outputs from elementary flows. We can select the airborne emissions. So first I will select low population density, because a coal mine is happen in a remote place where no population. Then first airborne emission data would be carbon. So we can filter here carbon dioxide. So we can obtain carbon dioxide fossil, right? And then another one is, so I will filter oxygen, and here would be nitrogen. So like that, I can enter all the airborne emission flows into the coal mining process. So here I have entered the all the airborne emissions from elementary flow into coal mining process in OpenLCA. Now I have to change the values. Here we know that for 1 kilogram of coal we have 1280. 1280. So like this, we can change the calculated inventory data amounts for each airborne emission. So you can see that I have entered all the airborne emissions data into the coal mining process that were found from the inventory data analysis system. Sometimes for a certain life cycle assessment, these emission data could be obtained from available databases as well. So after this example, I will show you how to use available data from existing database to model a life cycle in OpenLCA. But in this case, we can enter any collected data like this, as I explained. So to save the time for the tutorial, I am going to do the same thing and create the next two processes, that is coal transportation process and coal combustion process, and enter the same airborne emission data and accordingly the inputs and outputs, and I will quickly do it. The way is similar to what I did for this case. So I hope when you practice this example, you can follow the method. Of course, it takes some time when you model a life cycle inside a software, not only OpenLCA. If you use any other software like Simapro or Gabi or some other commercial software, you have to spend some time to model the life cycle assessment. Sometimes based on the data availability and relevance of the data, this time of developing the flows and processes and product system takes more time. Sometimes might be days or weeks or months or years. But in this case, since this is a pre-planned simple example, I can show like this. But for that, of course, I will take some time to enter each and every data. So I'm not going to show how to enter the data for each and every step in this video. I hope you can grab how to do it from this session. So I'll be back with the entered data for the three processes. Okay, now I have entered all the inventory data into the three processes in this example case. So here I have created, as I showed previously, the coal mining process. At there, the input is coal rock, and then the outputs are 1 kilogram of coal and the other airborne emissions from the entire coal mining process based on 1 kilogram of coal production. Then coal transportation process. There, I considered that the transportation vehicles are powered by natural gas. So the input would be energy from natural gas. That, of course, I selected from elementary flows available in the new database. And there, the amount of energy that is required for transporting 1 kilogram of coal. So there will be a certain distance to be considered, and like that. So I took it as 100 megajoules. So please consider that these are not exactly calculated values for this case. These are arbitrary values because I'm just showing you an example case study. Then the output, again, coal transportation, you can see that here when I create the three processes, there are three flows created with respect to that. So these flows are useful to show the mass flow from one process to the other process. So in here, for coal transportation process, 1 kilogram of coal transportation is the output, and there are other output emissions into the environment. So per 1 kilogram of coal transportation, these are the values I have entered according to the inventory data table in our example. Then the third process is coal combustion. And for the coal combustion process, here we have two inputs, that is the coal mining and coal transportation flows. So here we use the available two flows. Once we select them as inputs for the coal combustion process, automatically we relate the coal mining process and coal transportation process into the coal combustion process. And here the amount is given as a factor per 1 hour operation. It is required 60 tons of coal. So here, that is why I entered, as I can see from this button, it is 60,000 kilograms of coal mining, as well as 60,000 kilograms of coal transportation is required for 300 megawatt hours, because this is the 300 megawatt plant, 300 megawatt coal power plant, and for 1 hour the power generated is 300 megawatt hours. So for 300 megawatt hours, we have to use input 60,000 kilograms of coal. So like that we relate. And the other airborne emissions from the coal combustion process we have added here with the numbers, that is per hour emissions that corresponds to 300 megawatt hour power generation. There is another way to enter these values, that is creating parameters rather than just entering here the 60,000, 300, those things. There's another way to go for parameters and enter the parameters here, parameter 1, parameter 2, and parameter 3, like that, and define the values, then use the parameter name here, right? So that is an alternative method. I'm not going to show that alternative method. You can actually practice with this. Please, when you get familiar to a software like this, please play with that, and then you can learn yourself. So that is the best way to learn. So it's not difficult. You can create parameters instead of these numbers, but in this case I will go ahead with these numbers, just mention for your information and for your knowledge. Then I have created the three processes. Now the next step is I have to develop the product system. So I go to the product system. There are two ways. One is you can right click on product system and get a new product system, and there you can select the which process corresponds to your new product system, like that. But here I can, another alternative is I can but before going to product system, I think we should we can close this because we haven't saved these things. So we have to save whatever the processes that we have. So we can save. Another way is you can here you can save, right? So there are two ways. Rather than closing, you can save from file, right? Okay, so I will close all my three processes. Then I go for code conversion process, open it again. Then in the general information tab, here there's a button called create product system. So that's the second way to create a product system related to this process. So I select that, and code conversion is my reference process. So here it is, code conversion process is the reference process. Then so it's a system process, and these are, we can keep them as default, and then you can finish, right? Then now you can check whether we have correctly modeled this by going to the model graph. So you can see when you go to the model graph, you can see that this, you click this, so you can see that the coal mining and coal transportation processes have been connected to coal conversion process. So like this, actually the input for coal conversion is coal mining, and coal transportation we entered previously the two flows. So because of that, the supportive sub two processes have been connected to the main process of coal conversion. So that means our lifecycle model is correctly developed here. If it's not correctly developed, when we check the model graph, you can connect here, or otherwise you can check whether it's correct by just calculating the product system. So the next step is calculating the product system. So for that, we can go to the general information tab again, and here there is calculate button. So we can click on the calculate button, and we can see there's space to specify the allocation method. For this case, we don't have any allocation method. And then the most important thing is the impact assessment method. But we can see that in our new database, since it is an empty database, we don't have any impact assessment method. So what we should do is now, since we don't have any impact assessment method here, we should obtain the impact assessment methods from downloaded impact assessment method files. So previously we have downloaded the co-invent impact assessment methods, but it is in that database. So here we can see that they are available, many impact assessment methods. But now what we should do is we should export this to the new database actually, but it can't be done directly. We should export this downloaded impact assessment methods into one file available in the computer directory in a certain folder, and then we can import it to the new database. So that is the procedure we should always follow, not only for impact assessment methods, but also for data files insertion into a new database. When we work with our own data for a certain life cycle, we have collected our own data, but we need some set of data from an available database, then we can use the same procedure. Okay, so here what I should do is I will right click and I will export. Then there are several type of formats of the file. So here I will select the EcoSpold impact assessments impact assessment methods file, the file format as EcoSport, and then I click next, and I have to select the directory by clicking on browse. So already selected the same folder that I want is imported databases folder. Then I select the downloaded file that is available there, and I click finish. So here we can see that all the impact assessment methods available in this downloaded file are exported into EcoSport format, right? Now export part is done, so we can go to our new database again and go to the indicators and click on impact assessment method tab, and then now we can import. So the EcoSport one format, and click next. So here we can see that they automatically show the exported lifecycle impact assessment methods. Then I click, I select everything because I want all the package, because I don't know which impact assessment method is inside in this file. So I take the whole package into my new database, and I click next. Then I click finish, right? So it takes some time, and it will import all the impact assessment methods into the new database. Okay, it was imported, and now we can see there all the impact assessment methods are available, exported from the downloaded file and imported into our new database. Now the next thing is I go back to my product system called combustion again. Now I click the calculate button, and I can select, okay, it's automatically selected recipe midpoint hierarchical method because I selected that. That is based on the selection of impact assessment method, of course, depends on the location and the requirement of final results. So it decides whether it's required in midpoint or endpoint, like that. So anyway, for this case, I selected recipe midpoint hierarchical method. So I'm not going to explain more about the different impact assessment methods. I hope you will learn them in a general lifecycle assessment lecture. So or otherwise, if you refer any lifecycle assessment book. So then I can select here what I require. So analysis is the one I require. And you can see, for your further information, I would like to show here, there is a tab called Monte Carlo simulation is available, that of course for uncertainty analysis. In this example, I haven't done anything on uncertainty. For that, first we have to define the uncertainty factors of our inventory data. That of course based on pedigree matrix or any other method, and then we can use this Monte Carlo simulation tool in OpenLCA Software for uncertainty analysis. That part of course goes to advanced analysis that should be covered in another tutorial or a lecture. But for general work with general life cycle assessment work with OpenLCA, I think the analysis level is enough for this tutorial. So then I click next, because I can't include cost calculations also here because I didn't enter the cost data also, right? So then I can click next. There are several other options that we can select for data quality parameters and all. That of course we can keep it like that and click finish. Then we can immediately see our results. So if I want, I can export the results into Excel or save as another type of a file inside the OpenLCA. Then I can quickly have a look at my inventory results. So it has shown, and also the impact analysis. So in the impact analysis, we can see the major impacts like climate change, photochemical oxygen formation, particulate matter formation, and acidification. Like that, we can see the major airborne emission related airborne impacts have been calculated accordingly. And so this is how we calculate the environmental impacts for a certain product system, explained from this example case. Okay, now we discussed how to use OpenLCA software in order to model a life cycle and enter the collected inventory data by our own. So, but now I'm going to show you how to use existing data sets in OpenLCA software, as well as how to compare two life cycles. So that part would also be important for anyone who is working on life cycle assessment. So let's take an existing data set from a previously downloaded database. So I will right click and restore database. I previously downloaded the AgriWales database. That is a freely available database in OpenLCA Nexus website that of course covers many agricultural related processes and chemicals as well. So now I restored that, so I can open that existing database. So here I have, if I check the processes, I can see many processes are available, agricultural, chemical. What I'm going to do is I'm going to compare two chemical fertilizers in using the existing data sets, and I'm going to show you how to do it. So here we will go to chemicals and fertilizer inorganic and transformation. We can see many inorganic fertilizers production are available. So here, if we select one, the system boundary would be cradle to gate, I think. So we can check that also inside. So let's select urea and another nitrogen related nitrogen based fertilizer, that is ammonium sulfate. So how to do this? So we have those two processes in the database. So we will directly go to product system and we will click new product system, and for the first product system we will select the available processes from the database. I will go to the same folder and I first select ammonium sulfate, right? And then others would be it's a system process. I select it as a system process, then I finish, right? Then my first product system is ammonium sulfate, and the target amount or the functional unit I keep it as 1 kilogram. So I'm going to compare 1 kilogram of ammonium sulfate and 1 kilogram of urea life cycle for the production from beginning to the, from the raw materials to production of 1 kilogram of each inorganic fertilizer, right? Okay, so the next thing is I have to enter the next product system. That is, again, I have to select the existing data set or the process in the downloaded database, that is urea, right? So here at the very bottom I can see urea as nitrogen, because I'm going to compare the two fertilizers in nitrogen. If you have any knowledge about fertilizers, they can be interpreted based on the nutrient or a compound of the nutrient. So here it's elemental nutrient, that is nitrogen. So it's same basis, because it's very important to have each product system in the same functional unit basis for fair comparison. Otherwise, it's not a fair comparison in life cycle assessment. So now I have the two product system. Then I will go to projects, right? Then I will create a new project. That project's name is I would say chemical fertilizer comparison, right? Then I will finish that. Then I have created the new project here, chemical fertilizer comparison, and here I have to select the life cycle impact assessment method that I'm going to select again. So again I have to import the previously exported lifecycle impact assessment method package into this database, because this database also we don't have any impact assessment method. So I'm going to import the previously exported because folder. So now I import again, so it takes some time. Okay, so now I have to select the impact assessment method, so I can see that I have imported them. Then I go back to my chemical fertilizer production. We have to enter the product system that we want to compare. So compared product systems are there. So here I have an option. I can double click here. Then the available product systems that we have created are there. So I select both product systems I have previously created from the available data sets, and then you can see that option 1 and option 2. So here, if we want, we can rename the options. So the first one as ammonium sulfate, and the second one as urea. So now I have imported the impact assessment method. So here I can select the required impact assessment method. So here I will select again recipe midpoint hierarchical method. So you can see the impact categories are also shown. Then I can go to report sections, and if I want, I can edit the sections of the final life cycle assessment report, comparison report, comparison between the two product systems or many product systems. We can edit the report here, but I will keep it for as default for the moment, because this is just a tutorial. So I will go back to project setup, and I will click. Now I can click this report button. Then according to the selected impact assessment method, the two product systems will be compared nicely, and a nice report is created based on that report view section editing. So you can see here the single indicator results are there. I can change it to climate change. Like that, we can see a single indicator comparison, and that is a quantitative manner. And then the process contributions again. I will show for one. So what would be the process contribution? Then the most important thing is the relative results. We can see, we can compare for all the environmental impacts. Ammonium sulfate product system has higher environmental impacts compared to urea. So this is how we can conduct a life cycle assessment comparison, life cycle environmental impacts comparison in OpenLCA. So I did it for some existing data sets, existing processes, but of course we can create our own two or more product systems, and we can conduct the same impact assessment. So as a summary, we discussed how to conduct a life cycle assessment in OpenLCA software. In addition to the example cases that we discussed, there are many more life cycle assessment based analysis. Those could be performed using OpenLCA software. So I hope this video tutorial, consisting two parts, provided you guidance to get familiar with OpenLCA software for possible life cycle assessment work. This is useful for anyone who is working in the industries and who requires to conduct a certain life cycle assessment for a product or a process that he or she is involved in. And the other thing is all the university students, like undergraduate and postgraduate students, as well as researchers in this field, anyone who is working on life cycle assessment or related sustainability assessment can use OpenLCA software in a certain manner for their work. So I hope this video tutorial is a good guidance for you all. Finally, I wish you all good luck with your self-practice on this OpenLCA software. Please practice, then only you will be an expert in the software. So that's the end of this entire video tutorial, consisting of two parts. We will meet with another tutorial, probably not might be on OpenLCA, but related to various subject matters and other software training related to sustainability, chemical and process engineering fields. So that's the end, and have a nice day and goodbye.